Hello everyone, welcome to the first in a series on object-oriented programming. In this series we'll be talking about the design concepts involved in object-oriented programming, and we will be making use of pseudocode in our examples. Pseudocode is not code, but looks a lot like code, uses many of the same conventions, and quite often you'll find that you can transcribe pseudocode into actual working code with very few modifications. So what is object-oriented programming? Object-oriented programming is when programs are written in terms of objects and classes, and this differs from procedural or functional programming, where programs are written as a collection of functions, or sometimes termed modules. Here we have an example of the pseudocode for a program written in the functional or procedural style. We have two functions, task1 and task2, a boolean meaning a true or false value called program finished, which is set to false, and at the bottom we have our main statement, which is the starting point or entry point for our program. Inside the main statement we say, while the program finished variable still holds the false value, do task 1 and then do task 2 in a loop. So the program will perform tasks 1 and task 2 one after another until one of the tasks changes the value of the program finished variable, presumably when some condition has been met, and the program will finish. I have left the functions empty in this example because we are not concerned with what the program might do, we are just looking at the structure of the code. In contrast to the functional or procedural style, in object-oriented programming, programs are written in terms of objects that interact with one another. Objects are unordered collections of variables and/or functions, and variables within an object are called the object's properties, whilst functions within an object are called the object's methods. An object's properties are things an object has, for example name, age, height, weight, and methods are things an object can do, walk, run, swim, fly, and so on. Collectively, an object's methods and properties are called the object's attributes, or members. A class is a blueprint for an object, and when an object is created using a class, that object is said to be an instance of that class. When an object is created this way, we say the object has been instantiated, and we can then call this the object's instantiation point. So when an object is created using one of these blueprints called classes, the object is said to be an instance of that class. When an object is created this way, we say it has been instantiated and refer to its creation as its instantiation point. Here are some examples of classes and objects. Kevin is an instance of the person class. Lassie is an instance of the dog class. Mars is an instance of the planet class, and so on. Notice that in each of these examples, the object is a discrete instance. There is only one Kevin, and there is only one Lassie, but there are many persons, and there are many dogs. This is the correct relationship between objects and classes. Looking again at the planet example, we can see the objects Mars and Saturn are both of the planet class. Their size and distance from the Sun are different. However, they both have a size and a distance from the Sun. Objects of the same class can store different values, but they have the same structure. In our person example, people have different names, ages, heights, and weights, but everyone has an age, a name, a height, and a weight. Let's take a look at creating a class and some objects which are instances of that class. In this example pseudocode, we create a planet class which has properties, things a planet has, diameter, distance from the Sun, and mass, which all contain values. In this example they would be numbers. And every planet also has methods, things that it can do, for example rotate around the Sun. And methods, as we've said before, are functions. Underneath our class declaration, we create two instances of the planet class, Mars and Saturn. The syntax used to create these instances might look a little strange, as we refer to the planet class both at the beginning and end of these statements. This is sort of like C++ syntax, and it is not important for the purposes of this video that you understand why this looks the way it does. The important thing to understand is that in each of these statements we are creating an object which is an instance of the planet class, one being called Mars and the other Saturn. Here we see that we can access the members of Mars and Saturn and assign them values. In this way, Mars and Saturn are now different from one another. Notice that the objects are now storing different data, but that their structures remain identical, because they are different objects, but they are of the same class. As we've discussed previously, variables inside classes or objects are called properties, and functions inside classes or objects are called methods. Here is an example of a method being used. We have a class declaration for a class called dog, which has an age and a weight, as well as a bark method, which outputs woof woof. Underneath our class declaration, we create a new instance of the dog class, called Fozzie, which is the name of my dog, and then we invoke the bark method, which is a member of the Fozzie object, and this will output woof woof. Now we will look at an example of a program written in a mix of object-oriented and procedural style, where we have a class declaration called circle, which we have left blank for now, a function called drawCircles, which we have also left blank for now, a boolean value called escape, which is set to false, and our main statement, wherein we have a while loop which says whilst the escape value is set to false, just keep executing the drawCircles function over and over again. If we fill in our example class declaration circle, we want every circle to have a center x and a center y property, which are the coordinates on the screen for the center of the circle object, the radius, the color, and the display method, which we have left blank for now. But we know that this method will draw the circle object to the screen. Inside our function drawCircles, we set an integer I to the value 0, and then we say whilst I is less than 100, and then we have a series of statements for the code we want to be executed in each loop. The last line inside the while loop is an incrementation of the I variable, which means its value is increased by 1. This means that at the end of each iteration of this loop, the value of I will increase, and once the loop has been executed 100 times, I will no longer be less than 100, and the while loop will no longer execute, and then the drawCircles function will finish. If we look at the code we are executing 100 times, we can see that we are creating an object, which is an instance of the circle class, and then accessing the object's center x, center y, radius, and color properties, and assigning them random values. Then finally, we are calling the display method of the object. And this is all of the pseudocode necessary for this program. We can see that we are using a mixture of functions and classes, and that we are drawing circles of random size, color, and position in lots of 100. Now we will look at making this pseudocode more object-oriented, and we will do this by moving functionality away from our function, which is like a task or an event, and toward the class declaration, which is a blueprint for objects. The functionality which we will be moving is the assigning of each circle object random values. If we look at our updated class declaration, we still have the same properties and methods as before, center x, center y, radius, color, and display, but we have added the randomize method. The code inside the randomize method looks very similar to the code in the while loop, except instead of referring to the object, we use the term this instead. This is a keyword in most object-oriented languages, which refers to the object which has called the method. It does not usually refer to the class itself, but rather the object, which is an instance of that class and which has called the method. In our updated drawCircles function, we no longer assign random values to the properties of the circle objects by accessing them directly. Instead, we just call the randomize method on the object, which will then take care of changing the object's properties for us. Because this functionality has moved from a function to a class declaration, we can say we have made this program more object-oriented. Here's an example implementation of the pseudocode where the drawCircles function is executed once. This example was done in a web page using JavaScript and the HTML5 canvas tag. In the code, each of these circles is drawn by an object, which is a member of the circle class, which contains the functionality both to draw itself and to randomize its properties. So what are the advantages of object-oriented programming? Well, we can use objects in our code to represent objects in the real world. We can have many objects of the same composition whilst only having to define that composition once in our code using a class declaration. And we can bundle variables and functionality together in a more meaningful way. When we analyze systems and consider real-world scenarios, we are often thinking of these systems in terms of a collection of entities that interact with one another, a collection of things that have values and that perform tasks, or objects with properties and methods. Which style of programming is best, object-oriented or functional, broadly depends on the nature of the problem you are trying to solve with your program. But if you are thinking in terms of objects when you are looking at problems you want to solve or systems you want to model, then you will probably find it more efficient in the long run to adopt an object-oriented style. Other advantages of object-oriented programming include the use of concepts such as inheritance, method overriding, encapsulation, and polymorphism, all of which we will be delving into in much broader detail in future videos. If this video was helpful to you, please rate, comment, and subscribe. If this video wasn't helpful, please post me a comment and let me know why, and I'll see if I can do better next time, and I hope to see you there.